This is the first part of Chapter 2, exploring data with graphics and numerical summaries. First topic we want to learn is types of data. Second topic is difference between tables and graphics. So we want to learn the definition of variable and observations. Variable is any characteristic observed in a study. Observations are data values observed for a variable. Observations can be numerical value or categorical value. Here's an example. The green part is what we call variable or column headers or columns. For example, game ID, month game was played, or length of the time are variables or column headers. Observations are just the cells under those columns. For example, September, Tennessee, and 3.2. Those are observations. Two different types of variables. Categorical variables are those where each observation belongs to one set of distinct categories. For example, yes or no response and genders. Quantitative variables are those observations that take on numerical values that represent different magnitudes of the variable. There's measures or counts. For example, age, income, and the number of siblings. Note that not all number responses are quantitative. For example, phone number and zip code are not quantitative variables. There's a trick. If you take average of the variable and the average makes sense, then it is a quantitative variable. For example, average age, average income all make sense. However, the average phone number or average zip code doesn't make any sense at all. Hence, phone number and zip code belong to categorical variables. Discrete quantitative variables are those variables where the possible values form a set of separate numbers. The key phrase is the number of. The outcomes are counts, and for example 0, 1, 2, 3, and there are finite number of possible values. No decimals allowed. Continuous quantitative variables are those variables where the possible values form an interval. The outcomes are measurements. There are infinite number of possible values, and the decimals are allowed but are not required. Here is how you can determine whether a variable is categorical or quantitative. First, are the values of the variable numbers? If they are not numbers, they are a categorical variable. If they are numbers, answer the next questions. Would the average of all the values be meaningful? Is the variable a measurement or a count? If the average of all values are not meaningful, so it is a categorical variable. It is if the average is meaningful, and the variable is a measurement or count, then they are quantitative variables. To determine if a quantitative variable is continuous or discrete, here's option 1. Could the value contain a decimal? Not do all values contain a decimal, but could any value contain a decimal? If the answer is yes, then it is a continuous quantitative variable. If the answer is no, then it is a discrete quantitative variable. The option 2 is, are you counting the number of something, or is the value a measurement? If the counting the number of something, then it is a discrete quantitative variable. If it is a measure something, then it is a continuous quantitative variable. Here is example 2, variation of problem 2.3 and 2.6 on page 31. Identify variable type. Identify each of the following variables as categorical or quantitative. If it is quantitative, then state it is discrete or continuous. First, number of pets in a family. Usually it will be 0 pets, 1 pet, 2 pets, so it is quantitative and it is discrete quantitative variable. county of residency. This one is obvious. It is categorical, right? It is not a count of measurements. Choice of auto to buy, domestic or import. The answer usually just domestic or import, so it is categorical. Distance in kilometers of a commute to work. It is measurements, and decimals are also allowed. For example, 1.1 kilometers or 1.5 kilometers, so it is continuous quantitative variable. Social Security number. Okay, this one is number, but think about the average of Social Security number. The average doesn't make any sense, so it belongs to categorical variable. Last is the number of people you have dated in the past months. First, it is a number, and the average of number of people you have dated also makes sense. But are decimal allowed? Right? You don't date 1.1 people, you date 1 people or 2 people. So it is a discrete quantitative variable. Example 3. Football dataset. Identify whether the variables in the below table are categorical or quantitative. If it is quantitative, then specify if it is discrete or continuous. The game ID, they are combination of characters and numbers. But the average of game ID doesn't make any sense, so it is categorical. Months of a game were played. It is categorical. Conference versus the out of the conference game. It is also, its answer is yes or no, so it is categorical. Number of points USC scored. Usually 1 point, 2 points, 3 points, so they are quantitative and they are discrete. Length of time of the game. It is quantitative, and it could be 1.1 hour or 1.5 hours, so they are continuous. And the last one is the number of punts by USC, so it is also quantitative, and it's only 0, 1, 2, 3 are allowed, no decimal allowed, so it is discrete. Distributions of variables. The distributions of categorical variables show all possible categories and the number of observations falling into each category. And what to look for with categorical variables is how often each category was observed. The second is finding the model category. The category is with the largest frequency is the model category. Next question is what to look for with quantitative variable. The first thing you want to look at is the shape. Do observations cluster in certain intervals, and are they spread thin in other areas? The most common shape and the most important shape you need to learn in this method is called bell-shaped. I will explain later in this chapter. The second part you want to look at is the center. Where does a typical observation fall? The last is the variability. How tightly are the observations clustering around the center? Frequency tables are tables that list out all possible values of a variable with the following information. Note that not all following have to be given in a table, but they are all options. First is frequency. Frequency is the number of observations for each value, or we say the counts. Second is proportion. Proportion is the number of observations in each category divided by the total number of observations. This will be a decimal. For example, aka relative frequency. Last is the percentage. Percentage is proportion multiplied by 100, and it's changing the decimal to a percentage. Common types of graphics for categorical data. The first is pie chart. For pie chart, each category is represented by a slice of pie. The size of the slice corresponds to the percentage of observation in the category. Here is an example of a pie chart. Bar graphics is vertical bars for each category. Height of the bar is the percentage of observations, or the frequency of observations found in each category. Bars should not be touching. There's another type called a Pareto chart. It is bar chart in descending order by frequencies. Pareto principle, which states that a small subset of categories often contain most of the observations. This is an example of a bar chart. Here is example 4. This is an example about a home game or away game. The first, you need to know how to calculate the proportion based on this is what we call contingency table. The 58.33% is calculated as 7 divided by 12. And this proportion is calculated as 5 divided by 12. The entry percent is straightforward. It's just 12 divided by 12. This is the example of a pie chart. The A represents for away game, H stands for a home game, and we have 5 away game and 7 home games. And the area of A is 41.67% of the circle, and the home game, we have 7 home games, and the area of home game, or the red part, is 58.33% of the circle. And in the bar chart, we use the frequency as the measurements, and the height of the A bar is 5, and the height of the home game is 7. There are 3 common types of graphics we use for quantitative data. The first one is called dot plot, the second one is stem and leaf plot, the last one is histogram. Your lab instructor will show you how to use computer software. It's called StatQuant to generate statistical plots. I will help you understand what you can learn from those plots. The first example is about dot plot. This is an example about the number of cars sold in a day. We have 2 days that have 10 cars sold in each day. That's why we have 2 green dots above number 10, and we only have 1 day that have 3 cars sold. That's why we have only 1 green dot above number 3. This is an example of how to understand histogram based on frequency table. The frequency table here is data we have from the game called football game, and this is what we call interval. The first interval is shown in the graphic here, and the last interval, which is 550 to 599, is shown here. The height of each bar is controlled by the number of frequency. For the first interval, the height should be 2. It is controlled by number 2 here. And for the third interval, the height of this bar is 4. It is controlled by the number 4 here. If you manually create intervals, you want to make sure that your intervals are equally spaced and there are no overlaps, and every number is represented. Here is an example about the stem plot. First, I'll show you how you can relate the numbers from stem plot to the frequency table here. I will use this row as an example. As we can see, the stem number is 34 and the lift number is 3. We write down the stem number first and times the stem unit, which is 0.1 here, and we plus the lift number, which is 3, and times the lift unit, and we got 3.4 plus 0.03. The sum is 3.43, which is the first number in the frequency table. Now I will show you how to relate a number from the frequency table to the stem plot. I will use number 3.38 as an example. As we can see, there are always 2 digits in the stem columns. That's because the stem unit is 0.1, and all we need to do is find the first 2 digits, which is the stem number. The last digit is the lift number. So to relate 3.38 to the stem table in the left, we want to look at the row with 33, which is this row. And the number 8 means the lift number should be 8. So this number represents 3.38. There are some key informations you have to pay attention to when you read the statistical plots. The first one is mode, which is the most common value in the data set. The second thing is the shape of the histogram unimode or bimodal. The unimodal means there's only one peak in the data. The bimodal means there are 2 peaks in the data. There are some important information you need to pay attention to when you read the statistical graphics. The first question you have to ask yourself is, are there peaks in the data? If it is there is only one peak in the data, we call it the unimodal. This is the example of unimodal. There is only one peak. If there are 2 peaks in your histograms, we call it bimodal. This is the example of a bimodal. This is the first peak, and this is another peak. If it is unimodal, then we can use unimodal to locate the mode, which is represented by the highest bar. So first you find the highest bar, then you find the number in the x-axis. For this histogram, I will say the mode is probably very close to 0. If shape of distribution is unimodal, then data is either symmetric or skewed. Here is how you can determine whether it is symmetric or skewed. The first step is find the peak. Second, you want to do is compare the length of right tail and the left tail. If right tail equals left tail, and the distribution from middle the 2 sides are mirror images, then we say the shape of distribution is symmetric. Same thing for the skewed distribution. First, we find the peak. Then we compare the length of right tail and left tail. In this example, the length of left tail is almost 0. So we say it is skew to right. And for the last example, we do the same. First, we find the peak. Then we compare the length of the left tail and the right tail. We can see the length of the right tail is almost close to 0. So the last example is called skew to left. Another important shape you need to learn is called uniform distributed. If your histogram looks like this one, the height of each bar is close to each other, then we call this shape uniform shaped or uniform distributed. If there is a large gap between peak and isolated bar, then the isolated bar usually represents outlier. So this is what I mean by large gap. And this is what I mean by isolated bar. If the isolated bar appears, it usually means there is an outlier in your data set. Outlier means this number is much larger or smaller than the other numbers in your data set. We can compare weights of histogram. The wider the histogram is, the more spread it is. When we say compare the weights of histogram, the weights can approximately calculated by the maximum value. This is the maximum value and the minimum value in your histogram. So for this histogram, the histogram on the left, the maximum value is 7, and you subtract by the minimum value 3, which equals to 4. And the width of the right histogram can be calculated by the maximum value 9 and the minimum value 1. So the width of the right histogram is 8. So and 8 is larger than 4. So we can say the right histogram is more spread. Now you are able to do this homework.